Hi everyone, this is our IoT project. We developed Sport&Life, a platform for smart health and sport monitoring with the main aim to provide a service for monitoring wellness, training and fitness of an athlete or number of people who want to know is improving in daily sport life. The user is the center of the platform, and so we would like to present you the other components which are required to get the information about the physical situation that are the base on which our service begin developed. There are three IoT sensors. Starting from the right side of the screen, you can see a scale, a pulse oximeter and a smartwatch. Then a Raspberry Pi 3 that we use as a server and broker for our communication protocols.
The base of the entire platform are the data coming from real world. All our devices are the iHealth Smart Sensor, whose data can be retrieved through the iHealth Cloud. The communication with the iHealth Cloud is fundamental to retrieve data of every user, and for this reason an iHealth account is mandatory. Through REST communication, the iHealth adapter gets data every 10 seconds from the cloud and check if there is a new one to publish it via MQTT. In fact, the communication from here exploits a publish-subscribe approach thanks to MQTT protocol. So, when a new data arrives to it, the iHealth adapter publishes it on the right topic for the right user to the message broker, which is in charge to forward them to whichever microservice subscribes for that topic. When a microservice gets all the data necessary for a user to evaluate and extract some further knowledge about the user status, always through MQTT communication, the elaborated data is published to the user awareness. Now, a database containing all the personal information of all patients, it is necessary, and so a ThinkSpeak adapter is subscribing to some specific topic relative to each microservice, and all post-processed data are stored in ThinkSpeak platform that also help user to get a graphic view over time of every services. Other ways to show data to end user are Telegram that send messages and feedbacks when a new data from a service is available, and Freeboard that gives an overview of the general status of all these users, taking information directly from ThinkSpeak channel with the REST protocol. The catalog has a central role in the platform because it knows everything about all actors and allows the communication with REST or MQTT among them. User registration is made with a special Telegram bot. This registration is made with the same username and password of iHealth Cloud. Now it's shown the registration on iHealth Cloud website. However, a first login in iHealth Cloud is mandatory. Thus, the user gives permission to our application to use his personal data. And also, it is necessary for a security procedure of the iHealth Cloud. Thereby, the iHealth adapter can retrieve every information from now forever. Here there is the final part of the registration through Telegram bot and the communication between all actors of the platform, shown in three different screens. On the left top of the screen, the new ThinkSpeak channel is created and the user is ready to use the platform.
Here we can see an example of how data are collected by sensors and sent to the IoT cloud. The user is going to use the pulse oximeter, which evaluates his blood oxygenation and some additional parameters. The subject has to open the IoT application for mobile phone and follow the very simple procedure described in it.
Following the MicroStrategy approach in order to make it more scalable, we add 4 main microservices, but many others can be added with the same approach. Now we will explain in detail how they work. For the physical condition status service, the user must have the measures of step, fat value, BMI, blood oxygenation, and heart rate updated in the cloud with the respective dates within 24 hours. Analyzing some thresholds, a score is evaluated and one level of 7 ones is given to the user by a message in Telegram. In this service, the aim is to calculate the calories to reintegrate by burned calories during an activity and also the body water to reintegrate. Based on burned calories, the service recognizes if the user did an activity and classify it. This classification contains the information of calories must be reintegrated after the activity. Moreover, it's necessary to know also fluids lost during activity in order to reintegrate them. In fact, the data coming from the cloud must be in a period of an hour, in particular the distance route, the calories counted by the watch and the water percentage from the smart scale. This service returns the integration level based on a threshold, giving back also a message with the calories and the glass of water you must reintegrate. This service is thought to be evaluated after a sport or a strong activity. The service recognized if the user did an activity and tried to classify how it was strong and fatiguing relativity at the time it was evaluated. For this reason, the blood oxygen, the calories, and the weight must be taken in a period of a few minutes. The person will receive feedback about his status on Telegram with a message telling the level of fatigue. This service returns only a level based on a threshold to the BMI and water percentage taken from the smart scale and also the step. This service is effective with the measures in a period of 24 hours, and so the hydration level during days can be viewed. As before, a message is given in Telegram advising the user about the condition.
Now we can see a test regarding the publishing of all services after receiving data from IoT Cloud. In this section, we will see the whole platform in action. You should notice all the microservices running on different computers. In the left top screen, there are a Telegram user and 3 actors. The Raspberry, in which the catalog is working every time in background because receive always REST requests from other microservices, the fatigue services, and the Telegram bot. On right top screen is running the IoT Cloud Adapter, Physical Condition Service, and Freeboard Web Service. Another Telegram user can do something on the bot. In the end, on the third computer, we are running our FinSpeak adapter, iteration and reintegration services. The test is done with data that had been acquired before. If the incoming data are new, the adapter publishes it with the right topic relative to the device and the user. Finally, when services have published via MQTT post-processed data, the Sport&Life bot is going to send a message to user chats. Since we have 3 different kinds of device, we make requests in a thread loop every 30 seconds for each device.
It has been shown how the data are forwarded by the microservice that elaborates them and publish the result again with the correct topic for the relative user. For what concerns the user awareness, also the TeamSpeak adapter has received the post-processed data through MQTT. This actor published data on the specific published user channel created during the registration. The TeamSpeak web page shows graphics in which are stored all data coming from each service of the platform. Let's concentrate on Raspberry Pi. It contains the catalog web service that update data about the users, devices, and services through REST communication. This type of catalog makes the platform scalable, and new actors can be added, such as new device adapters or programs for user awareness either new control strategies. As seen before, Telegram bot receives the data from services, sending an advice message to the specific user. Users can connect to Telegram bot whenever and wherever they need. For example, they can ask for some graphic taken from TeamSpeak and also the last data of a specific service. In fact, in the video it is possible to note that the platform is running as explained before, and so 2 Telegram users are connected via PC. Moreover, other 2 users are connected using smartphone and iPad. Looking at the IoT adapter, new messages are coming from acquisition with IoT devices, and they are published to microservice in real time. Also, in this case, the user on the left top receives a real-time advising message. Meanwhile, Freeborn has received data from TeamSpeak and has updated its widget. On the iPad, we can see how easily a user can check his personal status from all services, asking from the specific command on Sport&Life bot. Also, in this case, every user has his personal dashboard. With this last section, we have seen all the main features of our platform. Thank you for your attention.